Following previous lecture, we'll discuss the concept of a magnetic field. Magnetic field is also created by electric current. Magnetic field is also created by an electric current. Electric current means flowing of electron. Flowing of electron. Flowing of electron I. Magnetic field is also created by an electric current. Magnetic field of a solenoid. If we place in compass, some compasses around a solenoid wire, then it is seen that the force on north pole of a compass, the direction will be the force on north pole of a compass. So the direction will be like this. Flowing current through a solenoid, and the magnetic field direction will be, if we place some compasses around the solenoid, then the force on north pole of the compasses will be the direction of the magnetic field. Then another rule is if we view from one end of the coil, if the current flows anti-clockwise direction, then that end will act as end pole. If we see from this end the current is flowing anti-clockwise, so this end will act as north pole or end pole. And if we view from this end and the current flow clockwise, then this end will act as S pole, and the direction will be N pole to S pole. Out of N pole into S pole. The field is strongest inside the coil, because here the field lines are more closer than the outside. So if we place compass or 2S, by placing some compasses and to see the force or north pole of the compasses, or to view from one end of the coil, and the current flows anti-clockwise direction, then that end will act as input, and current flows clockwise direction, then that end will act as S pole. and the direction will be from out of North Pole into the S pole. And uses of this magnetic field. This magnetic field is used to magnetize material to make permanent magnets. The strength of the field is also increased if we place an iron bar inside the coil. Then it will be 1,000 times stronger magnet. It will create the 1,000 times stronger magnetic field, and it will act as electromagnet. It will also use to make permanent magnets, and if we place an iron bar inside the coil, then the iron bar will act as electromagnet. If we disconnect the battery, then the magnetics of the electromagnet will be lost. So electromagnet can be switched on and off if required. So all moving charge, that means flowing currents, moving charge, flowing current creates magnetic field, and that magnetic field direction can be seen by placing some compasses around the solenoid or by viewing through one end of the coil and see that if the current flows anti-clockwise or clockwise. If clockwise, then that an S pole. If anti-clockwise, that an N pole. Magnetic field of a straight wire. Magnetic field of a straight wire. If we place some compasses around the straight wire, and it is seen that the direction like this. Direction will be like this by placing some compasses. Or another rule is right hand grip rule. Right hand grip rule. Here the thumb finger will indicate in the direction, will be sit in the direction of the flowing current, and the curved finger will show the direction of the magnetic field. So magnetic field like this. Field direction will be like this. If current flows, the magnetic field, the thumb finger points towards the flowing current, and the curved finger show the direction of the magnetic fields. So the magnetic field direction will be like this, and it is shown by concentric circle around the wire, and the field becomes weaker if we go beyond the wire. If we go far from the wire, then the field direction, the field strength decreases. So it is shown by near the center the gap will be smaller, and outside the more far distance the circles gaps will be larger. So the circles are drawn getting further apart. So as far as we have seen that all flowing currents create magnetic field around it, and the direction can be seen by placing some compasses around it, or for straight wire by right hand grip rule, and for solenoid the current direction anti-clockwise or clockwise as it was viewed from one end of the coil. And right hand grip rule is the thumb finger will point towards the direction of the current, and current finger shows the direction of the magnetic field. That's it.